Hello everybody, my name is Stephen Cornett and I am an urban farmer, regenerative farmer here in San Diego. I grow in I grow in Lemon Grove, so I grow in backyards and front yards of people's homes. And so today's talk is going to be all about regenerative agriculture, the future of agriculture, and how that relates to the soil, microbiology, and human health. And afterwards, I am going to be doing a 1-hour Q&A session over at the Maker's Tent here, and I also brought some produce to sell as well if you're interested. So here's one of my urban plots. This is my backyard. I actually me and my wife live in a granny flat in the back here, and I grow on 5,000 square feet. I also have a 200 square foot greenhouse where I'm growing microgreens, all my different seedlings, and my summer starts as well. And so I grow mostly leafy greens, chard, kale, collards, arugula, salad mixes, heads of lettuce. This is my other plot that I recently developed the last year. This was started completely no-till, and we're going to talk about no-till and why that's so important to the soil. Is the mic cutting in and out? Let's just switch to this one. Here's a picture of my salad mix, heads of lettuce. I do herbs as well, parsley, dill, cilantro. I have 20 chickens in my backyard as well, and they help me create a lot of the fertility on my farm. This is my farmer's market table at the La Mesa Farmers Market, and I sell there every single Friday. And what's special about my farm is that I'm trying to close the loop, and I grow about 90% of the nutrients on my own farm. So this is a little picture of my compost. I do thermophilic composting, so I'm trying to reach temperatures of 140 to 160 Fahrenheit in order to kill all pathogens and weed seeds and really create fast compost. I also do aerated worm and compost teas to increase the biology in my soil, increase the health of my plants. And compost and worm tea is a fantastic way to really increase the health of your plants, and they can actually resist pests and disease naturally. And on my farms, I use absolutely zero pesticides or synthetic fertilizers. It's all naturally done. And I'm going to talk more about how that's actually possible. I don't even use organic pesticides. A lot of people don't know, but the USDA approves organic pesticides. This is biochar. And biochar is charcoal that has been inoculated with microbes, fungi, and nutrients. And in 1 gram of biochar, there's actually a football field worth of square footage. So it's an immense amount of area that can be inoculated with beneficial bacteria. So it's a way of inoculating and repairing land. So I'm going to come back to this question a couple times in this presentation. And have you ever been to the Sequoia National Forest or the Red Woods or seen some of these incredible places, these very advanced ecosystems? Who is fertilizing this tree? How is all this biomass being created? I'm sure if you've had a garden before, you've bought fertilizers and added that to your garden. And we like to think that we need to add nutrients to our gardens, but this is not happening. These are hundreds of year old trees and no one added nutrients to them. So how are they growing? And I'm going to answer that question as we go. So I want to talk about the future of farming and what it should be, what it could be, if we get away from chemical-based agriculture and tillage. So currently, our current farm system, a lot of it is based in monoculture, which means they're growing one crop on large swaths of land. This is an asparagus farm out in the desert. So they're growing in land that is completely depleted. They're feeding with synthetic nutrients. It's very inefficient as far as watering goes. And I like to think of synthetic nutrients as an IV drip. So, I used to work in a hospital and people in the ICU, they would, give them the nutrients that they needed through IV. And that's exactly what's going on in the ground here. So we're going to talk about how the biology is actually breaking down the nutrients and allowing the plants to communicate with them in order for them to grow. And the same thing happens in our biome. The last speakers were speaking about the microbiome and how our food is actually broken down and made accessible by the microbes. So currently a lot of our animal production is done in CAFO, which means concentrated animal feeding operations. So you're seeing hundreds of cows per acre, when in a grassland grazing situation, it's 1 cow per acre. So they're also being fed a diet that is not made for how they were designed. And cows are called ruminants, sheep, goats. These are all ruminant animals. They have multiple stomachs. They're designed to eat grass, actually. They're some of the few animals that actually can eat it, break it down, and turn it into flesh. So what they're currently eating is corn and soy, which are grains. This is not part of the natural diet. And if you've ever seen, it's an older documentary, but it's called Food Inc. And in that documentary, they show what happens to the cow when they're eating this grain. And what happens is a bacterial overgrowth, and they actually have to feed them antibiotics and medicines in order to prevent disease from occurring. If they're eating these grasses, their natural diet, this never happens, and they don't have to actually have medicine. Now, all of these crops, corn, soy, wheat, beets for sugar, these are all genetically modified crops. And I really want to make a distinction between genetically modified organisms and plant breeding, because there's a lot of misinformation going on, being given out by the media and by the government, that GMO and plant breeding are the same, but that is not true. Plant breeding has been going on for thousands of years, and it's simply the cross-pollination of plants in the same species. So if you've ever seen patty pan squash, that yellow saucer-shaped squash, that's a hybrid, or there's many species of hybrid tomatoes as well. This is far different than what GMO is. GMO is combining the DNA from different species of plants all together. So one of the famous GMO crops is corn, of course. And what they've done with corn, they've made it what's called Roundup Ready, and they've done this by finding soil bacteria that is resistant to the herbicide glyphosate. And glyphosate is one of the most dangerous chemicals that we're currently putting into the ground. We now know that it does in fact affect mammal and human biology. For decades they told us that it had no interaction, and the reason that they thought this is because glyphosate interacts with the shikimate pathway, which is an enzyme creating pathway in plants specifically. We don't actually have it, but what we do have is biology. All of the soil biology, the biology on the plants has adapted over time with our own bodies. So when we consume foods that are doused in glyphosate, it's actually altering our DNA as well and our biome. So Monsanto is the company that has created this chemical. They were also the same company that created Agent Orange in Vietnam, which is the herbicide that destroyed thousands of acres of jungle during that war. So they have a long history of war against the earth. They're currently rebranding. They were bought by Bayer. So do not buy Roundup. It is horrible. So this is just a picture of it altering our gut biome. And a lot of the food in the center of the grocery aisle, anything with grains in it, if it's not USDA organic, it was probably sprayed with glyphosate, and it is damaging our gut biome, and it creates leaky gut. So that, I'm going to speak on this a little bit later. Oh, we got some rain. It's kind of a gross picture, but they've done rat studies on genetically modified organisms. They die sooner, and there's an increase in tumor growth. There's also been shown a decrease in fertility in rats as well. So there are many health effects that we have not yet realized from these genetically modified crops. So these crops are also fed, these corn and these grains, they're also fed to chickens. And you're seeing this person, the farmer here, he's in a gown because they're scared of bringing outside microbes and bacteria into the farms, and ooh, here comes the rain. And because of this, they have to feed medicines, antibiotics. It's not a living system where there's healthy bacteria that can fight off the bad guys. This is a drone shot that was actually shot illegally. It's illegal to film a lot of these CAFO situations. And that red liquid that you're seeing, that is all the waste from the pigs. And they drain it out and they let it run into this, man-made lake of horrible sewage. It goes into the groundwater. It's extremely damaging to the environment. But what I'd like to share with you is there is a way to process animal waste naturally, can actually incorporate it into the soil, and we can start to heal the soil with the waste products of animals. So no more negative stuff. Now we're going to talk about the positives, the regenerative ways that we can actually change our food system and the health of our bodies and our ecosystems. So I need to ask the question, should we mimic nature for farming? Should we use natural systems? Is that the way it should go? I think it is. That's nature's always right. That's So here's an example of a large-scale agriculture system. This is Mark Shephard's farm. He wrote a book called Restoration Agriculture, which is a fantastic book. And what you're seeing here is a diversified farm. This is an agroforestry system, which is combining trees, annuals, perennials, and animals throughout the system. Here's some cows that are running through the agroforestry system. And this is a way to incorporate the natural lives that animals want to live, while also providing the perfect food for them, which is grass. As they're running through these systems, they're pooping and peeing and adding their natural fertilizers to the system. They're also helping us prune the trees as they go through. They take out the water spouts and these lower lying branches. So they even help us farm and save us time. And it's very important that the animals are managed correctly. They're not allowed to stay here for a long period of time. They're moved every couple of days, because what we want to have is minimal soil disturbance. A little bit of disturbance is a good thing. It'll actually increase the production of the grasses, increase the health of the soil. And Joel Salatin here, I'm sure many of you have heard of him. He's the farmer who made this idea of pasture raising animals so popular and came up with a lot of different methods to make this a viable, profitable business for farmers. So what you're seeing here, this is pastured poultry, and this is the eggmobile that he created. And every single day, this eggmobile is moved to a new pasture. So every single day they get new grass, new bugs, new fungi to eat. And another thing that's really helped us with raising animal agriculture is technology. And what you're seeing on the outside fence here, that's an electrified fence. It's just run off a couple of car batteries. It keeps the animals safe from predators and also keeps them in that confined area so they're not escaping and getting out of there. Every single night they're put back in the coop and you collect the eggs. You can also do pigs in the same type of agroforestry system. And what's so cool about pigs is that they can eat the fruit or the nuts, the things that are falling down from the trees. So they're getting really beneficial nutrition. They're rooting up the ground, giving that soil disturbance, which is helping the soil to revive itself. And they use that electrified fencing in this situation as well. So, you know, the reason my company is called Nature's Always Right is because I believe that nature is perfectly designed, and we as human beings should steward these natural systems rather than trying to manipulate them and change them towards ways that we think are beneficial. And I think we've seen over the last couple decades of these synthetic systems, these monoculture systems, that they actually aren't as productive, and we're now seeing the health effects of them as well. And thank you to my mom. She's the one who created the name. So thank you, Mom. Love you. Why is Nature's Always Right, though? So in these agroforestry systems, we have a diversified landscape. You have wood that's going to create trees and nuts and more food. It's healing the soil structure, preventing erosion, allowing shade for your cows. All these different things that exist in nature that we're trying to mimic. When you increase the biodiversity on your farm, a lot of amazing things happen. You no longer need to use these pesticides because the natural pest-prey relationship starts to occur. And I've experienced this even in my small backyard farm, and also on the farm that I helped start 8 years ago with my friend Jared Smith of Jared's Real Food out in Lakeside. And as you watch the ecosystem develop, it's incredible. You'll see new species every single year that are predating on themselves, and of course we get insects, we get aphids, we get worms, but there's enough other life there that can prey on them, and a balance is actually achieved. So this is kind of an example of a diversified farm. They've got field crops, shrubs, vines, trees, annual crops, flower gardens, bees, all these different things that are creating a balance in this system. So this is what we're trying to achieve in natural farming. I want to introduce this idea of ecological succession, and this is really important to understand when it comes to natural farming, and it's just a really fascinating topic in general. So if you've ever seen an open bare lot, what are the first plants that start there? Is it trees? Is it an oak tree? Is that the first thing that arrives? No, actually it's the grasses, the weeds, the things that we don't like. And what is actually happening? These weeds and grasses are coming there to cover the land. Land needs to be covered. You know, if we had our skin exposed to the sun 20 or 12 hours a day, you know, we get sunburn and we, it would damage our skin. And it's kind of a similar thing to the soil. So that's kind of the first process, is to cover the soil's surface. After that, then the shrubs come, the brassica, the vegetables, eventually going into the softwoods, the hardwoods, to these more advanced ecosystems. All nature is trying to arrive at these further advanced ecosystems. So like the redwood forest, the Amazon rainforest, these are the end stages of ecological succession. So as we think about farming, especially these agroforestry systems, this is what we're trying to mimic. Also, in the beginning stages of ecological succession, the soil itself is more bacterial dominated. As you go up through the stages, it becomes more fungal dominated. Until the point of these the hardwood forests, it's about 70% or more, little more fungal dominated soil. So when we're growing vegetables, you want about a 50-50 fungal to bacterial dominated soil. And this comes into play later when we're talking about creating nutrients and indigenous microorganisms as well. So here's an example of human mismanagement of land. This picture is taken in China, and I think this is about a 20 or 30 year period. On the left here, you're seeing what is called desertification. This is caused by overgrazing of land. So I kind of mentioned earlier, we don't want the animals to mow the grasses or the plants all the way down to the bare soil. We want to take it down to a certain point so that the grass or the plants can regenerate, making them stronger. When you overgraze, taking away those plants, when it rains, the topsoil is washed away. And that very healthy soil that is needed for life and for propagating these plants is gone. So over time, a desert is created. You may have heard of the Fertile Crescent in Iraq, or if you think of the Nile River, it used to be much bigger. It used to have amazing vegetation there. It's no longer there because of the farming practices of farmers in the past. But what is so exciting is that we as humans have the ability to accelerate ecological succession if we steward land in the correct way. So this was done, I forgot it, about 20 or 30 year period. If you're interested in seeing a documentary about this process, John D. Liu is a filmmaker who made a great film all about this process going on in China. There's many greening the desert projects going on all over the world, in Africa, China, all over the place. It's really fascinating work. Also, Darren Doherty, Jeff Lawton, these are some of the people doing this great work. So going back to Mark Shephard's farm here and trying to mimic this idea of ecological succession and natural systems, I want to introduce you guys to some other ideas. So do you notice how there's these lines here? It looks really pretty. These are called contour lines. And if you could see the land flat, there's actually a slope that's going down this way. So what he's done is he's used what's called a Keyline plow to create contour lines, which are going to actually help soak in the rainwater. I'm going to show you a picture of that in a second. But we're trying to capture all the water into the land itself. And by doing that, we're helping to regenerate the soil, because now there's water. All life needs water in order to thrive. This is just another picture of his farm, and it's really cool looking. Here's kind of a close-up view of agroforestry. In agroforestry, the trees are planted usually on about 30-foot rows, and in between you're seeing what's called alley cropping. So you can grow annuals there, you can grow perennials there. As the system develops more, you can change up the crops over time. And you're able to collect a lot more sunlight because now you have vertical growth, not just the flat annual growth. So these systems can produce a lot more food on a smaller land base. You know, they can't produce as much, you know, as if you just did a monoculture of corn, but the overall poundage of food is far beyond that, and it's far healthier because you're getting a diversified crop also with animals. So this is what's called the Keyline plow. It was developed in the 50s or 60s by P.A. Yeoman in Australia. And they're the ones who invented this. And it's very different from a tiller, because a tiller is overturning the soil, mixing the soil, cutting it up, and killing the soil life. This is a little different. This actually gives lift to the soil. And what we're trying to do is get rid of compacted soil. For healthy soil, we need aerobic soil, or aerobic means it has oxygen. Anaerobic means it's very low oxygen. Anaerobic soils are not a place for the life that we want. So this plow cuts these little lines into the ground, gives it a slight lift, and this allows for better water infiltration, allowing for better root structure, and over time, healing the soil. So this top picture here, that's an example of compacted ground. You're seeing some of the grasses starting there. You come in with this subsoiler or the yeoman's plow, and it's allowing for that water infiltration, and then over time you can see the better root structures developing. The plants are sinking carbon with their roots down into the ground, feeding the microbes and creating a much healthier soil. This is just a picture. If you can picture, you know, a big mountain up above, and there's a valley that comes through. When it rains, where is the water going to go? It rushes down through the valleys. But if you've ever seen the terraces in China or Vietnam, what do? They create these amazing looking terraces. And this can also be done with a Keyline plow as well. And what you're doing is sinking that water into the mountain in order to grow food there. So now we're back at this picture of the tree. How did this tree get here? Who's fertilizing it? So now we kind of talked about some of the macro systems of agriculture and how that's all working, but now we need to go deeper. We need to go to the micro, and we need to talk about soil organisms and what's going on. So this is the soil food web, and the soil food web is very similar to like the circle of life that's on top of the soil, where pest and prey relationships are going on, but under the soil it's a much more complex system. There's trillions of these organisms. We've only scratched the surface of what we know about these things. We actually know more about space and the ocean than we do about the soil, which is pretty unbelievable considering how important it is to life on this planet and us, of course. So as we go through the animals here, you know, the birds, the smaller animals, they're feeding on these arthropods, the beetles and roly-polies. And as we go down further, they're feeding on the worms, the nematodes. Nematodes are kind of like a microscopic worm. They feed on the roots of plants, they feed on fungi, bacteria, and going down even further, they also help to create organic matter. And this is one of the most important things to have in our soil. We're always trying to increase organic matter. Organic matter is basically a gigantic sponge that can soak up all the water, is filled with these very complex organic acids like humic acid and fulvic acid, which are incredibly important to the growth of plants. And what I think is so amazing about plants, and something that really blew my mind, is how sentient they actually are. They're actually orchestrating everything under the ground. So what they do is they put out what's called an exudate. And an exudate is like a sugar or a simple carbohydrate. And it's something that tastes very good to the microbes and fungi. So in exchange for these exudates, the plant is getting the minerals and the nutrients that it needs. And it is literally communicating with the soil life to get these things. So it's kind of a new concept a lot of people don't know about, but we've unlocked a lot of secrets about soil biology in the last 20 years. And if you're interested, Elaine Ingham is a very famous soil scientist that you can learn a lot from. She's got many great YouTube lectures online. So What's happening is if the soil biology is there, the plants can get the correct nutrients. When they have the correct nutrients, they're able to have very healthy systems. They can actually resist pest and disease. They're also providing us all of the nutrients. A lot of the food that we're eating in the grocery store, like I said, they're giving them synthetic nutrients. They're just giving them what they think the plant should have. Nitrogen, phosphate, potassium, maybe some other micronutrients. But in reality, there's a lot more nutrients that plants need. And we have to get away from this reductionist thinking that we already have nature figured out. I hope that I've shown already how complex nature is. And we need to respect it and know that it is the orchestrator and not us. So if all of the nutrients are there, not only is there the right nutrients, but another thing that I think is so fascinating, on our actual food, the tomatoes, the leafy greens, there's biology on the food itself. And we have adapted over time with the soil biology so that when we eat food that has not been sprayed with chemicals, that has not been raised in dead soils, now we're being inoculated with that biology. And this is something that I think is so important that needs to be understood, and why local, beyond organic food is so important. Because not only are we getting more of the nutrients that we need to build healthy cells and bodies, but we're getting the biology that is going to heal our gut microbiome, which is the biggest part for most of the diseases going on in the world right now. Inflammation is basically the cause of most of our diseases. And currently, the gut inflammation, gut impermeability, leaky gut, is something that many of us are currently experiencing because of these chemicals like glyphosate that are changing our gut biome and actually create the impermeability. You know, our gut is, we're actually supposed to be completely separated from our digestive system. From our mouth to our back end is actually completely separate. It's not supposed to really interact until it's allowed to specifically. But when we have leaky gut, there's different things that are going into our actual tissues causing inflammation. And this is such an important thing that we've recently come to realize in science. So this is just another picture of basically if you have the correct microbiome, they are the ones breaking down the food for us. Of course, we have the stomach acids and all these things, but they're really important for the assimilation of nutrients. So I kind of like to think about my diet now is I'm feeding the microbes more so than I'm feeding myself, because we are actually 90% bacteria and fungi. If you look at the cells that are in and around our body, we're 90% that, 10% human cells. So the more we start thinking about how can I take care of the biology that lives inside of me or on my skin, the healthier that we're going to be. So now going forward, how are we going to regenerate the soil so that we can regenerate our land and our bodies? What are the systems? I've shown you some of them. This is not the way that we're going to do it. This is a tractor using tillage. So we're going to need to transition from tillage farming to no-till. This can be done on a small scale and a large scale. And what tilling does to the soil, it's mixing up all the different stratospheres of the soil. It's killing all the different soil food web creatures that I showed you. And it's actually unlocking the long chain carbons. There's short chain and long chain carbon molecules in the soil. It takes a long time for these things to develop. When we're tilling, we're destroying those, we're unlocking them, and in the short term, things do grow really well in tilled soil because it's unlocked all those nutrients for the microbes. It's infusing oxygen, making them more active, and now they're feasting on that, and very quickly we're experiencing the loss of organic matter. So this is, one of the reasons why the Dust Bowl happened. So I want to introduce this idea as well of the carbon cycle. This is something that's going on in Earth at all times. And so of course there's carbon dioxide in the air. The trees are absorbing that, and it's put down into the ground, into their roots, feeding the soil. And a lot of it is put into the biomass of the tree itself. It's put into the organic matter, the leaves. Animals that die, of course, are on the surface there, becoming a part of the soil as well. So how do we do no-till on a small scale? Well, this is how I do it on my small farm. So typically what I'll do is I'll add out compost. I don't till the ground. I just plant directly into that compost from beforehand. And these are soil blocks that I made. Now, there is some minimal type of tillage that you can use, and I do recommend in the case that you have compacted or clayey soils. This is called a broad fork, and what this tool does, it's kind of a similar concept to the subsoiler or the yeoman's plow that I showed earlier. And you basically crack the ground back, which is infusing some oxygen in there, giving that little bit of lift, but we're never overturning the soil, and that's the really important thing. When you overturn soil, you're exposing it to light and air, which is killing those microbes. Another way that you can do no-till, this is a direct seeder. This is a fantastic, great seeder called the Earthway seeder. And you just lay out some compost, make your bed flat, and direct seed directly into the compost. This is kind of what it looks like afterwards. Now, how do we do this on a larger scale? Because, of course, these backyard farms, I'm not going to be able to feed the world, even if we had 1 million small farmers. We do need larger scale agriculture, but can we develop systems that are no-till, that improve soil biology over time? Well, I'm very happy to share with you that that is possible, and there are farmers that have been developing these systems over the last 30 years. And Gabe Brown is one of them. I highly recommend listening to him and his talks. So this right here, you're seeing, this is a cover crop. And a cover crop is a diverse planting of usually it's legumes, which infuse nitrogen, grasses, which absorb a ton of carbon from the air and dump it down into the soil in the form of roots. Then they come and they actually just push it over, and they are snapping it, and the plant dies there on the top of the soil, and it decomposes there and becomes a part of the soil. They used to till in cover crops, but they developed this new method now where all that they have to do, they crimp down the cover crop, and they come behind with the next crop and seed directly into the cover crop. So the next thing of peas or corn or whatever it may be grows right out of that cover crop. Another thing that they're doing is that they're grazing the animals afterwards. So they could come through and eat the cover crop. And I actually talked to Ricky, who's one of the farmers over at Coastal Roots. They did a cover crop over there, and they had their chickens come through, eat, add their manure. And this is a way that we can incorporate animals into the systems as well, creating healthier meat, more sustainable meat as well. So I'd also like to talk about another thing that I think is going to be a part of the future of regenerative and natural farming, and it's called Korean natural farming. And this system incorporates what's called indigenous microorganisms. And these are organisms that are collected from that more advanced stage of the ecological cycle that I showed you earlier. And we want to collect it from there because they have the most diversity of microbes. The more diverse that they are, the easier they're going to be able to break down and convert our soils. Also with Korean natural farming, we can create our own natural nutrients. And I'm going to show you that. So this is how you collect IMO. This is one I did in my backyard. I haven't had the opportunity to go into the forest yet and collect my own more advanced ones, but I found the best area that I could in my yard, which would be next to the compost pile and the pecan tree and a lot of kind of dead wood. And what you do is you dry cook rice, and you allow the bacteria and the fungi to colonize this rice. Depending on the temperature, you're letting it sit for about 3 to 5 days. That was my first collection, not the best. This, guys, is incredible. That's a really good collection. So what you're seeing there is the microbes and fungi before they've bloomed. And what we do is we mix it 1-to-1 with brown sugar. And there's an osmotic pressure that pulls out all of the moisture and basically puts these microbes into a stasis where they're no longer active. They can't continue to eat. So we can stabilize them and store them. And we create what's called IMO2. And there's actually 5 stages of IMO that you can create, where you're incorporating more bacterial growth, more fungal growth, creating these hundreds or thousands of generations of adaptations over time. So some other nutrients that we can make, this is one that I think a lot of people here will like since you're at the Fermentation Festival. This is kind of how you make cheese. But what we're making is called lactic acid bacteria, or LAB. And what you do is, you know, if you've ever made rice and you rinse the rice and you have the wash water, well, you take that and you just set that out and you put it like a paper towel over the top. And lactobacillus there are billions of organisms that are all around us all the time. We're actually breathing them in right now. You may have heard of Lactobacillus acidophilus. That's in our yogurt. So it's something that is culturing for us. So we collect these wild microbes, we mix it 1 to 10 with milk. The milk kind of helps to culture the bacteria that we want specifically. And what we're left with is curds and whey. So the top is the curds. The center area, that is the lactic acid bacteria serum. And the bottom is the stuff that we don't really need for what we're looking for. It's kind of like a cottage cheesy stuff. I fed it to my chickens and they loved it. It was like a really good probiotic for them and some protein. And the top, this is the curds. And you can even make cheese from this. What's cool about the Korean natural farming is that many of these nutrients or inputs that we're making, we can eat ourselves. So I've drinking the lactic acid bacteria before, and it's incorporates a ton of great microbes for you. Here's the cheese that I made. It was my first cheese I ever made. It turned out pretty good, actually. It was yummy. Here's the actual finished product. So on the right is my lactic acid bacteria, and this is fantastic for outcompeting fungal diseases. It's very good for leafy greens. It helps with root growth. On the left here is fermented plant juice. Fermented plant juice is another Korean natural farming nutrient. And we can collect plants that are in their vegetative state, their fruiting state. You can do it with aloe, stinging nettle. There's a lot of different things that you can use. And basically what we're doing is we're collecting the microbes that are on these plants. We're putting them in stasis once again with 1 to 1 brown sugar. So we extract the microbes and the nutrients from them. Then you can spray that back out over the same crops, inoculating them with the beneficial microbes that they need and the nutrients. So it's incredibly fascinating. This is a way of doing organic agriculture extremely cheaply and freeing us from the debt slavery that a lot of farmers are currently in. Here's another one that I made recently. On the left here, those are cow bones. And what you do is you burn off all the organic matter, and what you're left with at the end is basically calcium phosphate. So you take that and you add it to fermented brown rice vinegar. The brown rice vinegar extracts the calcium phosphate, and what you have, that's my serum, and that can be sprayed onto your plants. In the picture before, you also saw eggshells. I was creating water-soluble calcium. This is a way that you could prevent blossom end rot, create much better fruit, better root structure, and it's all done naturally, very cheaply, from essentially a waste product. And I'll just talk about one more thing here that I really enjoy, which is called Bokashi. And Bokashi is there's like these grains here, they're called Bokashi grains, but they're inoculated with the lactic acid bacteria, and also you can inoculate them with the indigenous microorganisms as well. This is a company in San Diego that started recently called SD Microbe. And what's so fantastic is that you can spread this out into your compost to help accelerate the breakdown, inoculating it with more microbes so that when you do put it out onto your soil, it's going to create much healthier soil more quickly. You can also use this lactic acid bacteria and the Bokashi to create no-smell animal pens. So this is very famous in Korean natural farming, that you can have even an enclosed pig pen that doesn't have a smell, which is kind of mind-boggling to a lot of people. But what they do is they layer biochar, inoculated biochar, then they would do logs and then wood chips, and they inoculate all of that with IMO and the lactic acid bacteria, and these microbes actually eat the manure. So the smell is gone very, very quickly. And I've experienced this even in my own chicken coop, that now that I'm spraying that out, there's hardly any smell. So it's fantastic for an urban area where you might be bothering your neighbors with some of the smells. Now with this Bokashi, you can do something very cool, which is composting or pre-digesting any type of waste. So even meat, bones, I like to do my eggshells through it, dairy, a piece of cake, anything really. So this is a way that I've been able to not throw away any type of food whatsoever. The microbes pre-digest, and then once the bucket's full, you let it ferment for another 2 weeks. Then you take that when you're building your compost pile and add that to your compost pile, and it's really amazing. It's how I've been able to achieve such high temperatures in a smaller pile in my backyard, up to 160, which is really hard to do if you're just using vegetables and manure and straw. So I'd really recommend looking into Bokashi composting because it's such a valuable option for a lot of people. So just some final thoughts to leave you with. How can we promote this regenerative agriculture more? So of course, supporting local, beyond organic growers like myself. There's a lot more people coming to this field now, even in the city itself. This idea of urban market gardening is really starting to get big, I've noticed, and I think it's going to start to accelerate over the next 5 years. Of course, you should grow your own food at home. If you've ever heard of nutrient loss in vegetables, there's a famous study they did on spinach. A week after the spinach has been harvested, it loses 50% of the folate and some of the other nutrients. So the closer that you can eat food to harvest, the better, the more nutritious it's going to be for you, the better microbiology that's going to be on the food like we discussed earlier. And it's not washed, right? A lot of the foods at the grocery store, they've been washed in chlorine water, which is killing off the biology because they're trying to keep us safe and everything, but we actually want this healthy biology to enter our bodies. Of course, being at the Fermented Food Festival, we should eat fermented foods. The kimchi, the sauerkraut, all these different foods that are really going to help change our health dramatically. We want to rebuild our gut and our skin microbiome. So, don't use alcohol soaps, don't use antimicrobial things. We want the biology on us. And of course, please share the message of real food, regenerative farming, and some of the different things I shared with you. And I hope that you learned some cool new things that you hadn't heard before.